Hello, Channing Benson, Splits Experimentation Advisor, here with another video. This one's on using the split sample size and sensitivity calculators. So the first question is, what would you use these calculators for? And that's to answer the question of how long do I need to run my experiment to be able to see the desired swing or the expected swing in my key metric. And there's a couple factors that go into this, and the calculators take those factors into account and give you an expected duration for the experiment. The input of the calculators is some information about the metric, about your key metric. Hopefully you have some baseline information about your key metric, such as what is the mean, what is the standard deviation, and you use those as inputs to the calculator. You also need to know the expected number of visitors that will see the feature that you're experimenting on, the percentage rollout for that feature, and then the desired MLDE. MLDE is minimum likely detectable effect. So if your hypothesis for your experiment says we're expecting to see a 2% uplift in conversions, then your MLDE is 2%. The calculators take as input your seasonality period. For most people, that's going to be 1 week. The output of the calculators, there's two different calculators. There's a sample size calculator, and that is given a desired minimum likely detectable effect and the amount of traffic and that information about your key metric. How many days will I need to run that experiment in order to see the minimum likely detectable effect if it exists? The sensitivity calculators take a slightly different approach to that and give you a relationship between the minimum likely detectable effect and how long you would need to run. So in other words, it tells you if you want to see a 5% increase in conversions or whatever your key metric is, then you'll need to run for X many days. So two different swings or two different approaches of viewing the same sort of data. So I mentioned that there's two different types of calculators, the sample size calculator and the sensitivity calculator. There's also two variants of each of those. So there's 4 calculators in total for the sample size calculator and the sensitivity calculator. Each of those has a variance for 2 different types of metrics. One is a means metric, where the metric is expressed as a mean of some value. The other one is a percentage of unique users metric, where conversion is a typical example, that how many people who saw this feature, what percentage of them actually went on to buy a product.
All right, so now I'll run through 2 examples. One, I'll use the sample size calculator with a means metric, and then I'll use the sensitivity calculator with a percent of unique users metric. So to find the sample size calculators, the easiest way is to go to help.split.io and then search for sample size. And you'll see the first suggestion there is sample size and sensitivity calculators. Let's go there. Here's the page. It explains some information about how the calculators work, some of the defaults it uses. So here's the one we're going to use in our first example, the sample size and experiment runtime calculator for means metrics. And you'll notice that it needs a baseline metric value and a baseline standard deviation. And these will be the values of the metric, your key metric for the experiment, for your existing version of the split, so the baseline you're going to use to compare against. And so you'll need a place to get these values from. Perhaps it'll be a back-end system that you have current data for, or the easiest way is to get it from an existing split. If you have a split that has that metric for that particular version of the treatment. And one place you might see that is in an AA test. So for instance, here's an AA test, and we've got a baseline, which is our off treatment. So let's go look at bookings per user at the metric values for that, and we'll pull those values to use in the sample size calculator. So the ones we need are for the baseline, the off treatment, at 0.36 for the mean, 0.48 for the standard deviation. And for smaller numbers, you may want to hover so you get a more precise version of the metric. But in this case, the 2-digit versions, 2 significant digit versions are fine for our uses here. So let's grab those values. The baseline metric, the means was 0.36, and the standard deviation was 0.48. So we enter those in here. What size change do we want to be able to detect? So in other words, what is your hypothesis saying you expect the swing in this metric to be? Let's just say we expect to see a 2% increase. And our sample size per day, let's just use a nice round number of 10,000. And our rollout, so this is the number of new unique users you expect to come to your site and see this experiment every day. And that'll be used in calculating the sample size and the duration. And what is the rollout percentage? We'll go with a 50-50 here. How many days in the seasonality cycle? Typically that's going to be a week, so you include one day, one instance of every day of the week, and weekends in particular are days where users might behave differently than during the week. So there's we filled in all the values. We do submit, and it gives us a result very quickly, and says to measure a 2% difference to your metric, you will need at least 139,536 users. So we recommend running your experiment for 14 days. So now let's do an example using the sensitivity calculator. If you scroll down, there's the sample size calculator for percent unique metrics. Continue scrolling and we get to the sensitivity calculators. And so we're going to look at the experiment sensitivity calculator for percent unique or proportion metrics. And notice there's only the baseline metric value here. There's not a standard deviation. So let's go pull that from our AA test. Let's look at a metric that's a percent of unique users. So here's booking, percent of unique users. We click on that. We make sure we're on the last dot so we have the most data. And what is our mean? 35.77%. So let's grab that. And 35.77. What is our expected sample size per day? Again, 10,000, 50-50 rollout. And notice it's not asking us for an MLDE. It's not asking us to see, how big of a swing we expect, because what it's going to do when we submit is it's showing us a chart that says if we want to see a 1.5% swing, how long do we need to run for? In this case, 28 days. If we want to see a 1.64%, 21 days, and then very similar to our earlier test, if we want to see a 2% swing, we need to run for 14 days. So this sensitivity calculator is useful if you really want to see what's possible given given the number of users to your site and a reasonable amount of time. What is the amount of swing in your metric that you can expect, that you will see if it exists. So you might be constrained by the number of days you can run the experiment. So if you're constrained to 14 days, then a 2% swing is the smallest you'll be able to see. Here's some couple different versions of seeing that data. Here's showing you the actual number of users going in. So, with a total of 280,000 users over 28 days, you can see a 1.42% MLDE. So that's the sensitivity calculator for means metrics. You can see how it differs from just the sample size calculator, and then it gives you a range of choices here. So there's a couple of examples of using the split sample size and sensitivity calculators to get some information about how long you need to run an experiment. So what are the big takeaways here? I think the primary one is don't fly blind. Take advantage of some pre-experimental analysis to make sure that your plan for the experiment is going to be able to reveal the desired variant or the desired uplift in your key metric for that experiment. You don't want to get 2 weeks into an experiment and find out you don't have enough sample data to really see the percentage swing in the key metric that you wanted to see or expected to see. And these calculators are a really good way of doing that pre-experiment analysis. The calculators, I would also recommend, even if you don't have a particular experiment in mind, they're interesting to play with numbers, to do some scenarios. Make up some data or look at your baseline data for one or more of your metrics and feed it into the calculator just to give yourself a sort of realistic
perspective on how many users you need to run through your experiment to see effects of a particular size for that metric. And that can be educational in a statistical sense as well. Channing Benson, Split's Experimentation Advisor, signing off.